Let's talk about power of compounding. At the beginning of this section, you're going to notice here is some helpful information, and we're talking about the exponential rules. So I'm going to let you take a minute. You can pause it, go over this, and let's just jump right into solving these problems. On this first part here, it says evaluate the following. If you look at example 1A, you'll notice that it says that it has 3 to the 4th power. That 4 is a positive power, so that means that we're good. If it was negative, I'll show you what will happen. What we want to do is write this in a format that's easier for us. So when I say 3 to the 4th power, that just means 3 times itself 4 times. I know some of you have calculators that you can type it in, and it will give you 3 to the 4th power. It's good to understand the process before you use it. So I have 3 times 3 is 9, and then 3 times 3 is 9, or you could have went 3 times 3 is 9 times 3 is 27, and so on. Now I could say 9 times 9 is 81. So 3 to the 4th power is 81. Now let's look at this one here. I want to rewrite it. We all know what 3 squared is, but what if it was 3 raised to the negative half? Well, let's work with that. So if it's a negative power, we're going to flip it because we can't have a negative power and solve, right? This is not our final answer. And to put that in, some calculators give you an error, but we need to flip it. We need to rewrite it where it makes the power positive. So we're going to rewrite it like this. And now I got 1 over 3 squared, which is 1/9. Right? And if you have any questions about exponentials, I have a video that I've went thoroughly through the rules and the setups and the negatives and all these. So definitely check those out. Now, if you look, we have 2 cubed times 2 to the 4th. This means I have a base raised to a power. If my bases are like terms, or not so much like terms, if our bases are alike, then we can put them together and then use the rule of multiplication of powers. So we're going to say 2, I'm going to write it once because I'm going to put it together, raised to the 3rd plus raised to the 4th. Whenever you multiply like bases, you add the powers. So now I have 2 to the 7th. And then again, that's the same as saying 2 times itself 7 times, which gives me 128. Okay. Now, if we divide by like bases, we subtract the top power minus the bottom power. And remember, it's always written as numerator read first over denominators, and numerator is the top power. So if you want to rewrite it where it makes better sense to you, go right ahead. But the bases are alike, so I'm going to write it once. I'm going to raise the top power minus the second power, which gives me 3 squared, which is 9. Now, let's talk about when our power is in fraction form. Whenever it's in fraction form, it's talking about power over root. I see that I have 25 as my like base, and it's been divided. So I'm going to write it once, and what it tells me is you always subtract the top power minus the bottom. So I have a half minus a half, which gives me what? When you take a half minus a half, and I believe this is a typo because I meant for this to be a negative half so we can add them. But in this case here, I did not do that. So let's talk about that right quick. So if I have a half minus a half, we know what we get is a 0, right? So if I gave you a half, took away a half, gives me 0. Let's talk about that. That means 25. Let me find my pen again. So if I would have kept it in this format, I'm going to erase mine. Let's just keep it alone. So I would have had 25 to the 0. That's if I would have said, oh, okay, we're going to leave this as a positive. So then that would have been just a half minus a half, right? Gives me 25. So anything other than 0 raised to 0 power is 1. So that would be 1. I intended on this to be a 1 minus a negative half, which would have added it, but that's okay. We could do that right here. Let's just go ahead and do it now. So what if it said a minus a negative half? Then that would have been half plus that half, which would have been what? 2 over 2, which would have been 25 raised to the first, excuse me, which is 25. Now I'm going to take just a second on this power and just tell you the top number is power and the bottom number is root. So it told me that 25 was raised to the first power with a root of 2, meaning the square root of 25. But since we had the like bases, we combined the powers. We came out with just 25. Now let's do F. F says we have 2 cubed plus 3 cubed. Well, here we go. We do not have like bases, so we can't put them together. So 2 cubed is 8. 3 cubed is 27. We add them up, we get 35. The next one said just solve for y. So if we're going to solve for y, I need to get it by itself. And it needs to have a positive 1 coefficient. Well, it has the positive 1 coefficient, but it's not isolated. So I'm going to subtract the 4 from both sides because it was positive. Now I got 7 minus 4. So y equals 3. I got 2x equals 18. Well, the coefficient on x is 2, and I need it to be a positive 1. So I need to divide by the 2. And what you do to one side, always do to the other. 18 divided by 2 is 9. All right. Let's isolate the y value in part C by subtracting that positive 1 to both sides. And then let's divide by the negative 6 because I need a positive 1 coefficient on y. Because negative divides negative is positive. 6 goes into 6 once. Negative divides positive is negative. 6 goes into 12 2 times. And there's our answer. D. Let's get all of our x terms or variable terms on the left-hand side. That's the side I like to always set because we get used to reading left to right. So we're going to subtract the 6x from both sides. So now I got this. And some of you are going to skip that step, and that's okay. Now I got a positive 5 here, so let's subtract it from both sides. I got negative 4x minus 6x, meaning that I was in the hole $4, spend 6 more, now it's negative 10x. I got negative 5 minus a negative 5, which is negative 10. And let's divide by that negative 10. And now I get x is equal to 1. All right, we're doing pretty good. Some of these you'll probably have no problem with. If you need to skip past this section, go right ahead. As long as you understand how to solve it. Let's do E and F for sure. It gets a little bit more complicated, and then I'll let you do G and H on your own. E says I have 2x divided by 3, and it's in a fraction. So I cannot solve for x as long as it's involved in a fraction. So what I want to do is I'm going to say, okay, the denominator is 3 here. If I multiply every term by 3, I can undo that fraction. So I'm going to multiply each part by 3. Oops, don't forget the x. So now 3 over 3 reduces down to 1, leaves me 2x. 3 times 4 is 12. 2x times 3 is 6x. And now let's get the x terms on the other side, on the left-hand side. And let's subtract the 12. So now I have 2x minus 6x. It gives me a negative 4x. Equal to negative 12. Let's divide by that negative 4. So now I have negative divides negative is positive. 4 goes in 12 3 times. Now let's do F. I want to do F right quick, and then I feel confident y'all can do the rest. If you notice on F, y is raised to the 3rd power, and we need to undo that. So if it's raised to the 3rd power, then the 3rd root is what will undo that power. And what you do to one side, we always do to the other. So now I have y is equal to cube root of 27. This is saying that something times itself 3 times gives me 27. Well, that's 3. And that's my answer. All right. So let's move on. If you want to take a minute and pause this and read it, there's some helpful information here. We have our formulas that we're fixing to use and what it means. And while you do that, let me go over this. Okay, so let's get started. So example 1 said, oops, back up here. Example 1 says, while banks almost always pay compound interest, bonds usually pay simple interest. Suppose you invest 1,000 in a savings bond that pays 10% simple interest per year. How much total interest will you receive in 5 years if the bond paid compounded interest? Would you receive more, less, or the same amount of interest? So looking at this, I know if I take the $1,000 that we're going to invest and I multiply that by our 10%, of course, we need to convert that to decimal. So you can either take 10% and divide it by 100%, or you can do the shortcut and move the decimal 2 places to the left. And when I do that, now I get this. And when I multiply 1,000 by 0.1, it gives me 100. And then we said that how much will it be in 5 years? I'm going to take that 100 and multiply it by 5, and I get $500. All right, that's my answer. All right, so let's do our next one. Our next one says you invest 100 in 2 accounts that each month, here we go. 100 in 2 accounts that each pay an interest of 10% per year. But one pays simple interest and the other pays compound interest. Make a table to show a growth of each account over a 5-year period. Use the compound interest formula to verify the result of the table compounded interest case. So make sure that whenever you decide to do business with a company, what is the difference between these two? If they told you one was simple interest, another one's compounded interest, and you didn't know what it is, this is something you want to know about before you actually do it. So let's get started. Our beginning balance is $100, and we're doing 10%, which I'm going to write it in decimal form because that's how we're going to use it, right? But our answer is 10% there. Now, our simple interest says that we're going to pay our simple interest paid. If we start off with $100 and we times it by 0.1, we get 10. So we have 10 here. Well, 100 plus that 10 gives me 110. Okay. Now let's take that $110 and multiply it by 0.1 because that's how much is in there. The interest is going to multiply to what's in there. So if I take that 110 times 0.1, we're doing simple interest, are we not? Simple interest says that we're going to have 10%, 10 paid on 100 all the way through for that 5 years. So I'm going to add 10 to that 110, which is 120. I'm going to add 10 to that 120, it's giving me 130, so on and so on. So in 5 years, we'll have $150 in that balance. Okay, that's if you add no more to it. Now, let's look at the compounded interest. That's where it becomes a little bit different. So we take that $100 again, and we multiply by that 0.1%, and it gives me the $10. So that's the $10 plus the 120. Sorry, guys, I was looking at the other table. $10 plus 100 gives me 110. So now I'm going to take that $110 and multiply that by 0.1. So in simple interest, they calculate what you're going to occur at the very beginning, and then they're going to apply it all the way through. Compounded, it's going to compound on the amount that's in there. So if you put more money in, it's going to give you more. So 110 times that 0.1 gives me $11. I'm going to put 11 here, and I'm going to take that 110 and I'm going to add 11 to it, and it gives me $121. And then I'm going to take that $121 and I'm going to multiply it by 0.1. Oops. And I could do the shortcut. I was just double checking. So it gives me $12.10. I'm going to add that $12.10 to that 121, and we get 133.1. Or you can put 10 cents there. And then I'm going to take that and times that to 0.1, and that gives me $13.31. And we're going to add that to that 133.1. So I get a new balance of 146.41. Take that 146.1 times it 2.1. And now I get $14.64. And let's add that to that 146.41. Whoops. Okay, so it's 161.05. So, I mean, you're going to actually get more money, or you're going to accrue more interest on a compound interest because it's compounding on the amount of money that's in there versus simple interest where they just, that was one time based upon that amount, and that's how much you're going to accrue every time. Okay. So, oh, and there's my total box where you would have wrote the total. If we compared it, the compounded came out to be $11.05 more. I'm going to let you do this number 3 on your own and try it out. Reach out if you have any questions. And let's do this next one right here. So it says your grandfather puts $1,000 under his mattress. Oops, excuse me, guys. 50 years ago. If he had instead invested it in a bank account savings, or a bank account paying 3.5% interest compounded yearly, how much would it be worth now? All right, so let's do that. Let's use our formula of A equals 1,000, because this is what we're investing, right? That's what he put under his mattress. So in 50 years, that's what he still has, right? Plus, what is our interest? 3.5%, but we're going to write it in decimal, either by dividing by 100% or moving the decimal 2 places to the left. So we get, oops. Yeah, get this right. A little bit neater. And then we're going to raise it to the power of 50. So if you need to go back to that formula at the top, go get it. It will help you. Now, whenever you're doing this on your calculator, some calculators, you can literally type it in the way you see it. It's going to give you the answer. Some calculators, you have to use a bunch of parentheses. So I'm going to do it in parts for those of you that don't have the calculator that allow you to do it all at once. So I got 1 plus that decimal. That worked out great. So next I'm going to take that decimal and I'm going to raise it to the power of 50. And I'm not going to round on my decimal number just yet. I will round at the very end. Some of y'all's calculator will round a little sooner than others. So now I got that times 1,000. So we're going to round to the nearest hundreds, 2 decimal places, and the nearest cent. So it's $5,584.93. So if the grandfather would have put that in a bank account that was actually paying an interest of 3.5% compounded yearly, then he would have $5,584.93, which is what, $4,584.93 more than that $1,000 he has at the moment. So, I mean, not everybody likes bank accounts, but when you go find a place that you would like to put your money in to invest to let it grow, do some research on it. Make sure the interest doesn't change as far as dropping. Maybe it goes up and give you more interest. Make sure that you don't lose anything. You know, read everything finally and compare. All right, let's go to this next section. I'll give you a minute if you want to write it down. You may want to pause this to write it down so we can use the formula next. And let's move on. It says you deposited $5,000 in a bank account that pays an APR of 3.25% and compounds interest monthly. How much money will you have after 5 years? Compare this amount to the amount you have or would have if interest were paid once per year. All right, so let's do this. I'm going to grab my formula and I'm going to recognize what part's what. My 5,000 is what I got to invest. I'm going to add that to my interest here, my rate, right? So my rate, I need to write that in decimal form. So let's move the decimal 1, 2 to the left. And then my N, it said it's going to be compounded monthly. So it's going to be 12 because there's 12 months in a year. I'm going to raise it to N times Y. So N is compounded monthly, which is 12 months. And it says over 5 years because Y is years. So now I'm going to do this in steps again. So we need to clean up inside this parentheses. And you can go ahead and say, what is 5 times 12, right? That's 60. And then I'm going to say 1 plus. Now that fraction you may need to do separate if your calculator don't allow you to do it in fraction form, or use parentheses. So when let me give myself some space here because I don't want to round on my decimal just yet. So I get 1.002708333. My calculator stopped about right there. I'm going to take that number and I'm going to round it to the 60 power. So now I have 5,000 times that 1.176189933. Now multiply that by 5,000. Now let's round to the nearest cent. So we get $5,880.95. Okay, so now it says we're going to compare that if it would have paid interest once a year instead of monthly. Okay, so this is monthly, the interest paid. Now let's do once a year. So I'm going to take that $5,000 we're investing. I'm going to take that 1 plus that interest, and I'm going to raise it to 5 years. So now I have, I'm just going to go ahead and do my extra steps. Okay, so now we have 5,000 times 1.173 411,396 times 5,000. So it gives me $5,867.06 if it compounded once a year instead of monthly. I could subtract the difference, and If it compounded monthly, I would actually earn $13.89 more. Okay, so let's look at our next one. What do we got next? All right. So now it says that we have use the appropriate compound interest formula to compute the balance of the following. So we have here $20,000 for 5 years, APR of 3% compounded daily. So daily means 365 days of the year. So I'm going to take my formula. A equals the 20,000. 1 plus, I'm going to write this in decimal form. And it's a daily, so it's going to divide by 365 because it's compounded daily. And then it said for 5 years, so 365 times 5. I do not have a lot of room here. I should have made some space, but let's do this. We have 1 plus that fraction. So we have 20,000 times 4 zeros, 829, or 82192. And we got 365 times 5 raised to 1,825. So let's do this. I'm going to do it all in one line this time. And I get $23,236.55. If you round, so it could have been 54, depending on your rounding. You could have rounded sooner. So just watch out for the rounding thing, okay? If, I would encourage you to go ahead and write the last digits. Oops, and this should be approximately, guys. If we round, it should be approximately. I'm going to encourage you, if you're submitting written work, to write out the whole decimal and then say equals and write out the whole decimal and then approximately and then round it. That way, if your rounding's off by the answer, could be the calculator rounded sooner or whatever, you would get credit because this is correct. And then this would be correct, So it could be a calculator rounding thing. But anyways, let's move on. Let me get my mouse to work. All right, so the next one said that we have 20,000 for 5 years, APR 3%. That did not, compounded annually instead of daily. So let's write this out. We got 20,000, 1 plus the interest, all divided by 1, because it happens once, 1 times the 5 years. So now I get A is equal to 20,000, 1.03 raised to 5. Let's double check my math. So now I get $23,185.48. Okay, now let's go. I'm going to pick a different color here. So the next one says we have 15,000, 20 years, APR of 3.7% compounded quarterly. There's 4 quarters in a year. So we're going to take A equals 15,000 times that 1 plus the 0.037 divided by 4 raised to 4 times 20 years. So now I have A is equal to 15,000. 1 plus that fraction. And I'm going to raise it to 80 because 4 times 20 is 80. And then get this long number here. Now let's multiply that by 15,000. Okay, so now I have 31,332.27. Now I want you to do this annual compounded annually and quarterly. The next one's on your own. Just reach out if you have any questions. So let's move on. If you want to take a minute and pause it so you can get all this information down, I encourage you to do that. And so we can move on. So the next one says that you deposit $1,000 into an investment with an APR of 8%. Find the annual percentage yield and the quarterly, monthly, and daily compounding. All right. So if you notice, you're giving these formulas here. And it's telling us that we have an annual interest rate. And we're going to compute this right quick. 1 second. We might have to go back up and get our formula. I didn't carry it down with me. Sometimes that helps to have it already printed out and have it sitting beside you when you're working on this section. Or any of the sections that requires the formulas, I strongly encourage you to do that. It would be useful and helpful for you. Give me 1 second. I'm finding my formula. My apologies without scrolling the screen. May have to do that. All right, so we can do that. We can find our APY. Let's scroll up and see what our formula was. It's called the effective yield, or yield is the actual percentage by which the balance increases in 1 year. It is APR if interest compounded annually. It is greater than APR if interest is compounded more than once a year. To find this, calculate the actual interest earned for 1 year, then divide the interest by the principal and multiply by 100 to put it in 100%. Okay. So that was good. So those of you that paused it and actually wrote that down, good job. So let's do this. So we have, I'm sorry, guys. Give me just a moment. I'm having my moment. Okay, so we have a quarterly annual interest. So we're just going to use our formulas. Keep it the same. It says we're going to do this annually. And so I'm fixing to write this down for you. My Thank you for being patient with me. Okay, I got it. My apologies. Yes, we're going to use our regular formulas and then we're going to apply this other rules. I kind of overthought this. So if you do that, don't feel bad. You're not the only person that overthinks it. All right, so we're just going to use a regular formula because we are just compounding it, right? We're compounding it quarterly, monthly, and so on. So let's go ahead and write what we know. We got $1,000 that we're investing. We got 1 plus our interest rate, and it's not changing. So that's great. We can use that over how it's compounded. Quarterly is going to be compounded 4 times. Monthly is 12. Daily would be 365. It's all going to be multiplied. Well, we're talking about 1 year. So the annually, however we compound it in, is how we're going to compound it. Y is the year. In this case here, Y is going to always be 1 because that's what they asked you to do. So take that and plug in. So I'm going to erase some stuff and I'm going to plug in. So we got 4. So we're compounding it 4, right? Quarterly. We're raising it to 4 times 1 year. We get 1,082.43. So if we get 1,082.43, subtract the 1,000 from it, we get 82.43, right? And then I'm going to take this and we're going to put it in decimal form, right? I'm going to move the decimal, well, it's in decimal form, but we're going to move it to the left. It's going to give us the 0.0. And actually, let me just explain what this is telling us. We're going to take that 1,000, that 82.43, right? And that's the principal. And we're going to take this 82.43 right here, plug it in as an annual. We're going to divide it. So 82.43 divided by 1,000 gives us this. Now we can multiply it by 100% and we get 8.243%. All right, let's do this again. All right, so now what happens? We're doing monthly, so no longer have 4 and we got 12. So now take that 1,000 and we're going to factor in 1 plus that fraction because the interest didn't change, but it did change how it compounded. We're going to raise it to the 12 times at 1, or yeah, 12 times at 1. And now we get $1,082. And oh man, we get, let me erase this. Let me show you what's going to happen because we're going to round this and something's going to happen here. We get 1,082.999507. And if I round to the nearest hundreds, that 9 causes this 9 to go to 10, which I got to carry the 1 over, causes that to go to 10. Then I got to carry it over. So it gives me 1,083. Subtract the 1,000 from it. So I get 83 here now. That's my annual monthly interest. We're going to take 83 here and divide it by the 1,000. And we're going to get 0.083, multiply it by 100%. And now we get 8.3%. Let's do the same thing to the next one. The next one says, okay, it's daily. So let's do it daily. Let me erase some of this because it's kind of messy looking. So if we're doing it daily, that's 365 days, right? In the year. So this changes right here. This changes, and we're still multiplying by 1. So let's type that in our calculator. The interest didn't change, but how it compounded did. Okay, so now I got approximately 1,083, and I'm going to round to the nearest hundreds. So it's going to be 28. Subtract that from 1,000, subtract it from what we originally deposit, gives me 83.28. Now I'm going to plug the 83.28 right here and divide it by that 1,000 that was invested. And it gives me this. I'm going to multiply it by 100% here, or you can move the decimal 2 places to the right, and I get, this is my percent. All right, so if you overthink that particular one, don't feel bad. It's easy to do. All right, now let's talk about compounding continuously. Here, if you want to take a minute, write it down, pause the screen, whatever you need to do, I would. Now in the formula, so that way we can start working it out. All right, so you deposit $1,000 in an account with an APR of 8% and continuous compounding. What is the value of the account after 10 years? So let's write down what we know. We have a deposit of 1,000. That's my principal. That's my investment. Guys, if you don't understand what each part of this formula means, I would strongly encourage you to write it down. And my eraser not working. All right. So A is my go. It's what I want to accumulate. It's what I want in the end. P is my starting principal, my investment, what I'm applying, what I'm depositing. E, it said to use this right here. So if your directions tell you to use that, use it. If not, you have one on your calculator, use it. APR is the annual percentage rate. And then you got converted decimal, and Y again is the number of years. So I have a investment of 1,000, and I'm going to times it to E raised to, and my interest is 8%, but I got to convert it to decimal, so it's 0.08, and it gets multiplied by the number of years. So next, I'm going to do it in steps this one time. So I'm going to take that 0.08 times that 10, and you're going to get 0. You're just going to move the decimal to the right one place. All right, now let's put it in our calculator. So I got 1,000. I have the E mode in my calculator, so make sure if you have trouble, just reach out. I'm gonna raise it to 0.8, and I get $2,225.54. Okay. We are almost done. So our next part says we're going to compute 1, 5, and 20-year balance for the following accounts that are compound continuously. So A says we have $12,000 with the APR of 3.5%. The B says we got $3,000 with an APR of 3%. I want to do A and let you do B on your own. Make sure you understand how to do it. We're compounding it continuously, so we're still using this formula. Make sure I write it neat. So I got 12,000 E raised to, and I'm going to turn this to decimal. Take it out of percent. And it said that we're going to do it for 5 years, or 1 year, 5 years, and 20 years. So this Y is going to change. So for the 1 year, I'm going to take that 12,000 E raised to 0.035, yes, times 1 year. So I get 12,427.44. Let's do when it is 5 years. And I get 14,294.95. Now let's do it for 10 years. Oh, sorry, 20 years is what it asked for, wasn't it? and I get 24,165.03. So go ahead and take the time to figure out the next one on your own. Reach out if you have any questions. So we're almost done here. Example 7 here says that suppose you put money in an investment with an APR of 3% compounded monthly and leave it there for the next 18 years. How much would you have to deposit now to realize 100,000 realize 100,000 after 18 years? Okay. So basically, it wants to know to get an in-go of $1,000 is what is, sorry, not 1,000, excuse me. What this is actually asking us is, what do I need to deposit today in order to have $100,000 in my account in 18 years? So we don't know the principal now. We just know the outcome, the in-go. So my A now becomes that 100,000. I don't know what my principal is. I do know what my interest is. My interest is 3%. I'm going to write it in decimal. And then it said it was going to compound monthly, right? So my N is 12. I'm going to raise it to 12. And I'm going to multiply that by 18 years. So you could do, there's multiple ways to do this. You can go ahead and say, oh, I need to get P by itself and divide P by that whole entire parentheses and move it. Or you can turn this parentheses and that power to the decimal number and then move it. There's more than one way to do that. Just be careful on your rounding if you do it too soon. I'm going to go ahead and say, let's take this over here and let's divide it. Again, you can go ahead and get it in decimal form and then divide it. It might be a little neater, less writing, a less likelihood of having a typo. And of course, you could have a typo with the decimal number. So now I have P is equal to that 100,000 divided by that parentheses. I'm going to go ahead and figure out what is that parentheses. So I got 1 plus that fraction. I'm going to raise it to the power of 12 times that 18. And now I get 1.714850874. Now let's divide this out. Be careful with the zeros. You leave one off, that 100,000, and it's going to change your answer significantly. So, and I'm going to round here. I get $58,314.11. I would have to deposit today in order to have that 100,000 at the 3% interest rate, compounding monthly for the next 18 years. Okay. And the last one says, how long will it take your money to grow by 50% at the APR of 7% compounded? All right, well, let's take our formula again and let's plug in what we know. 50%. So we can take that 50%, put it in decimal. So take our A equals P times that 1 plus the APR divided by N raised to NY. We're going to plug in my principal. We are missing right here. So here's the thing. if we're going to take 50% of, we want it to grow by 50%, right? And when we compound our money at 7%. Yes, we are missing some information in this question. My apologies, guys. So what do we have here? If I said that I am going to invest the $100 and I want it to grow in 5 years. Oh, how long are we're solving for Y. Okay. My apologies, guys. This question here just missing a little bit of our information, but then again, it's good. All right. So we know what our interest is. We're going to write it in decimal form. We're going to compound annually. So my Y is 1, right? We're trying to figure out how many years it's going to take to get 50% for it to get up to 50%. So let's say we're going to deposit $100. Again, let's just say that's the part that's missing. And I want to know how many years it's going to take me to, or how long, right? It'll take me to do that. And it says compounded annually. So N is 1 and we're solving for a Y. Okay. We're not really solving for Y, but we are. I'll show you what I'm talking about. But I do apologize. We were missing the deposit amount. So I'm going to say, okay, I got A equals 100 times 1 plus the APR, which is 0.07, divided by 1 because it's compounded once. So if I said in 10 years, how much money would I get? Well, we'll get 196.72. Well, it asks to increase by 50% of what we deposit, not almost doubled, right? So let's try out 7 years. So if I take it 7 years, I get 160.58. Okay, we're getting close. Let's try 5 years. So we're just plugging in for Y to see how long it's going to take us to double our money. And we get 140.26. So I'm going to say about 6 years, in between 7 and 5 would probably be it. Let's try 6, see what it gives us. Well, that gives us $150.07. So I'm going to say it's going to take 6 years to double that money.